Problem 9, fx is it's ln x to the power of cosine x. X is greater than 1. Okay, here you can't use a chain rule. If it's ln x to the power of a, right, or it's a to the power of cosine x, you can use a chain rule. However, if both sides contain x, you can't use a chain rule. Right. So here, what should you do? You can use the implicit differentiation, but before that, so here's the problem is x is on the power, right? Remember, ln a to the power of b is b ln a. It can move the power to, right? It can change a power to multiplication, so we can ln both sides. Right. But before ln both sides, you have to make sure both sides are positive. So you can see when x is greater than 1, this is greater than 0, then this is greater than 1, greater than 0, right? As long as this part is greater than 0, the result is greater than 0. So you can safely ln both sides. Okay, when ln, it's ln y. This part, you can bring cosine x down. So it's cosine x ln x. So now you can do the implicit differentiation, d over dx ln y. It's d over dx cosine x times ln x. Okay, here it's use a chain rule. First ln something, the derivative is 1 over something, right? And then y, it's dy over dx. This part is a product rule, right? It's this part's derivative. This part's derivative, which is negative sine x, right, times ln x. Plus this part times this part's derivative, right? So plus cosine x times this part's derivative. So what is ln x's derivative? Again, use the chain rule. First, it's ln something, so it's 1 over this, right? And the second part, you ignore ln. It's ln x's derivative, right? It's 1 over x. So it's cosine x times ln x times 1 over x. Okay. So in the end, dy over dx is y times the right side, right? You move y to the right side, so it's y times the right side. So y is, right, y is just ln x to the power of cosine x, right? This part is y. This part is your y. Okay. Times this whole thing. It's cosine x. It's cosine x over ln x minus sine x ln x. Okay.